Two-stroke engine, detailed explanation, advanced level. Two-stroke engine definition. A two-stroke internal combustion engine completes one thermodynamic cycle in two piston strokes and one crankshaft revolution. It produces one power stroke per revolution, making it more powerful than a four-stroke engine of the same size. Main components include cylinder made of cast iron or alloy steel with ports instead of valves, piston of aluminum alloy with compression and oil rings, airtight crankcase for precompression, inlet, transfer, and exhaust ports, spark plug for ignition, and carburetor for mixing air and fuel. 1. Working stroke 1 from 0 to 180 degrees, compression and suction. The piston moves from bottom dead center to top dead center. The air-fuel mixture compresses with pressure rising to 6 to 10 bar. Vacuum in the crankcase draws fresh mixture. The spark plug ignites at approximately 180 degrees. 2. Working stroke 2 from 180 to 360 degrees, power, exhaust, and transfer. High pressure of 30 to 40 bar pushes the piston down. The exhaust port opens, releasing burnt gases. The transfer port opens, allowing fresh mixture to enter, pushing out exhaust gases. This process is called scavenging. Types of scavenging. First, cross-flow with ports opposite each other and a deflector piston, an older design. Second, loop scavenging with an upward angled transfer port that loops fresh charge for better efficiency. Third, uniflow scavenging with one-directional gas flow used in large engines, providing highest efficiency. Thermodynamic cycle. The cycle follows the Otto cycle approximately, involving compression, constant volume heat addition, expansion, and exhaust. Real engine processes overlap, causing less efficiency than the ideal cycle. Lubrication system. Small engines mix oil 2 to 4% with fuel, causing smoke and fouling. Modern engines may use separate oil injection systems to reduce these issues. Advantages. Higher power-to-weight ratio. Simple mechanism with no camshaft or valves. Compact design and lower initial cost. Disadvantages. Lower thermal efficiency. High fuel consumption. Poor scavenging efficiency. High hydrocarbon emissions. Shorter engine life. Applications include small engines like motorcycles, chainsaws, lawn mowers, and heavy-duty uses such as marine diesel engines and some locomotives. Thank you for exploring the detailed workings of the two-stroke engine with us. Subscribe for more advanced engineering insights.